Hey guys, so we have a change of venue at home, but I do want to teach you guys how to do the math for today, just in case you don't join the meeting. That's okay. So we're going to do lesson 37. I can transition or move from the 4 partial products to the standard algorithm for 2-digit by 2-digit multiplication. So notice that we are going to do the standard algorithm. I'm still going to do the 2 partial product or the 4 partial product as needed, but I'm also going to show you how to do the standard algorithm. So I am going to skip the review slide again, and I'll do that during the lesson if you wanted to come to the lesson. So let's look at the application problem. It says Sylvie's teacher challenged the class to draw an area model to represent the expression 24 times 56 and then to solve using partial products. Sylvie solved the expression as shown. Is her answer correct? So she did what we learned yesterday, which is really today, on Monday. She's using what we learned on Monday. So let's look. So she's represented 24 correctly and 56 correctly. Go ahead and look at the answers that she got and see if they match up. I'll give you some time. So this is 4 times 50. Is 4 times 50 200? Yes. 4 times 5 is indeed 20, and you bring over your 0. That's correct. We go here, 4 times 6 is 24. Correct. Okay, now we have 20 times 50. 2 times 5 is 10, and then you have 2 zeros to bring over, so it looks like she did not get that correct. So let's correct that for her. And as for the final one, it would be 20 times 6, and that would actually be 120. So it looks like she got 2 of these wrong, which means her answer is going to be wrong. So let's come off to the side and find the correct answer for Sylvie. So I'm going to take 1,000 plus 200 plus 120 plus 24, and we should get our correct answer. 0 plus 4, 4. 2 plus 2, 4. 2 plus 1, 3. 1 plus 0, 1. So we actually found the answer 1,344 if we added those correctly. There's always a chance we didn't. So let's move along. How do we multiply 2 digits by 2 digits using the standard algorithm? So unfortunately, only way to learn the standard algorithm is to practice the standard algorithm, because at first it might seem hard to you. So we're going to take our 26 times 35. We're going to write it out like this, where the numbers are stacked on top of each other vertically. And we're going to start with the 5. We always start in the ones place. That 5 is going to visit the 6 in the ones place, and then the 5 is going to visit the 2 in the tens place. And I would cover up the 3 if I could. I would take my finger and I would place it over the 3, just to pretend that I'm doing 26 times 5 first. So 5 times 6 is 30. Leave your 0, carry your 3. And then the 5 goes to visit the 2 in the tens place. 5 times 2 is 10. You add your 3 and you get 13. So I have 130 right there. So I'm going to mark off the 5 and I'm going to mark off the 3 so I don't get confused. Now that 3 is going to go visit the 6 in the ones place and the 2 in the tens place. But before we do that, we have to remember, we have to use our brains and say, hey, we're in the tens place now. So in multiplication, when we're doing, multi-digit numbers, we have to put in a placeholder, and that placeholder is a 0 because we want to shift over into the tens place. So let's look at 3 times 6. 3 times 6 is 18. If you are having trouble with your multiplication facts, use your B-binder. You have a chart right on the back. And then 3 goes to visit the 2 straight up. 3 times 2 is 6, plus 1 is 7. So once you get these two rows, you add them together, kind of like what we do for partial product. You add them up. 0 plus 0 is 0. 8 plus 3 is 11. And 7 plus 2 is 9. That's our answer. Arguably, that is much faster. So let's do the box method. So we're going to start with the 2 partial product and then draw our horizontal line to make our gift, our 4 partial product. We're going to put in our 26 on this side, and you know 20 goes here, 6 goes here. What goes here? 30 and 5. Now, for those of you who don't need to do it this way, who can simply look at 6 and 30 and multiply them, you don't have to do this step. You can skip that step. But for those of you who need it, 6 times 30 is 180. 6 times 5 is 30. 20 times 30 is 600. 20 times 5 is 100. And then you take those numbers, and I'm going to use the space off to the side. 600. Be very careful when you are lining them up, or you're going to add wrong, and that's a stupid reason to get this wrong. 0 plus 0 plus 0 plus 0 is indeed 0. 8 plus 3 is 11. 6 plus 1, 2, 3 is 9, and guess what? We found the same answer. So naturally, we're going to do it again. So this one says, how do we multiply 2 digits by 2 digits using the standard algorithm again? So we're going to just do it again. 43 times 67, those numbers are stacked on top of each other, and we're going to start in the ones place with the 7. He's going to go up and visit the 3 in the ones place, and then he's going to go over and visit the 4 in the tens place. So 7 times 3 is 21. You're going to leave your 1. You're going to carry your 2. And then the 7 is going to go over to the tens place and visit the 4. 7 times 4 is 28 plus 2, 30. And remember, you can mark these off because you've already used them. And before we let the 6 go and visit anyone, we have to remember that we're shifting over to the tens place. So that means we have to put a place value. And that place value is going to be a 0 right there in the ones place. So let's do 6 times 3. We go back to the ones place first. 6 times 3 is 18. Leave your 8, carry your 1. And then you go up to the tens place. 6 times 4 is 24 plus 1, 25. Make sure your numbers are all lined up. 1 plus 0 is, 0 plus 8 is, 5 plus 3 is, and 2 plus 0 is 2,888. Now, we're still going to make one of these box method partial product rectangles. So just like our 2 partial product, we start with 2 segments, and then we go to our 4 segments. So go ahead and label your rectangle. We have 43 on one side and 67 on the other. So I know that we're going to have 43 and 67. And again, for those of you who don't have to do this step, you can obviously skip the step of writing out the multiplication sentences, but I'm going to do 3 times 60 because the 3 goes to visit this rectangle. We look to the left and we look up, and this rectangle, we look to the very left and we look up. 3 times 7. You can solve them as you go. That's what we did last time. I'm going to write the multiplication sentences first this time. Just in case you like one or the other, you can see them both done that way. This rectangle is going to be 40 times 60. And this rectangle is going to be 40 times 7. And now we can solve for the answers. Again, the box method takes significantly longer than the standard algorithm. So really practice the standard algorithm because that's what you're going to be expected to use in the future. So 3 times 6 is 18 with an 0 added. 3 times 7 is 21. 4 times 6 is 24. Bring over your 2 zeros for 2,400. And 40 times 7 is, in fact, 280. So now you have your 4 numbers, and I'm going to come over to the side here. Put my biggest number first, 2,400, 280, 180, and 21. We're going to add those 4 numbers up. 1 plus 0 plus 0 plus 0 is 1. 8 plus 8 plus 2. You can do 8 plus 8 is 16 plus 1 is 17. Leave your 7, carry your 1. 4 plus 2 plus 1 plus 1. I'm going to imagine that to just be 4 plus 4. And that is 8. We've done something wrong. I've done something wrong. I've added wrong. Because right here, if you notice, I hope you noticed because I didn't. 8 plus 8 is 16 plus actually 18. So I'm going to fix that mistake. 8 and 1. So that's still an 8 there, and then we bring down our 2. So 2,881. So I hope that mistake didn't mess you up too much, and I hope you caught it before I did. We have a couple left. So we are going to do 24 times 36. And again, if you feel like I'm going too fast, you need to stop me by pausing me or rewind me. Let's do the standard algorithm, 24 times 36. So we're going to start in the ones place with the 6. And we're going to do 6 times 4 first. We're going to go up to the ones place first. So 6 times 4 is 24. Leave your 4. Carry your 2. And then the 6 is going to go visit what number? The 2. So 6 times 2 is 12. Plus 2 is 14. So I'm going to mark off the 6. I'm going to mark off the 2 because they've been used. I'm not going to use them again right now, and I don't want to confuse myself. So now we have to move over to the 3, but I have to remember that I'm also moving place values. I'm going from multiplying the 1s to multiplying the 10s. So I have to put in a place. The word escaped me. I have to put in a placeholder, and that placeholder is a 0 in the 1s place. So now we're doing 3. 3 times the numbers that we have left to multiply. So 3 times what first? 3 times 4. And 3 times 4 is 12. You're going to leave your 1, leave your 2 and carry your 1. And now we have 3 times 2, which is 6, plus 1 is 7. So we're going to add these up, and we're going to find our answer. 4 plus 0 is 4. 4 plus 2 is 6. And 7 plus 1 is 8. 864. So we're going to do the box method and see if we got that right or wrong. Because if one of my answers is different than the other one, I know one of the methods is incorrect. So let's put our 24 in and our 36 in. I'm going to give you a second to do that and check my phone because I want to know who texted me. Okay, so let's put our 24 in. We have a 20 and a 4, a 30, a 6. This is nothing new. And now we're going to solve for those 4 smaller rectangles. So I'm going to start right here, as I always do, with 4 times 30. 4 times 3 is 12. Bring over your 0. Now we're going to do this rectangle with 4 times 6, and that's going to be 24. Let's go down here. We have 20 times 30, and that's 2 times 3 is 6. And then you bring over your 2 zeros. And then we have our last rectangle, and we're going to do 20 times 6. 2 times 6 is 12. Bring over your 0. And now we have our 4 numbers, and we're going to add those together. 600, 120, 120, 24. So 4 plus 0 is 4. I hope you know that. 2 plus 2 plus 2 is 6. And 6 plus 2 is 8. And we did, in fact, get the same answer, which makes me believe 864 is the correct answer. Let us do one more together, because practice makes perfect. Again, how do we multiply? I didn't make this slide, but it's a mistake I would make. 2 digits by 2 digits using the standard algorithm. So this time they want us to do it without an area model, which is perfectly fine because practice makes perfect. We have 37 times 49. And again, it's hard and you just got to do it. But your parents learned this way, your grandparents learned this way, so they should be able to help you with this way. So let's take a look. We're going to start where? What number are we going to start with? Because I like to circle it every time. So what number do I circle in the beginning every single time? Look for those patterns to help you. The 9. That's what you guessed. You're correct. So the 9 is going to go visit which number first? The 7. So what is 9 times 7? 63. How many of you are actually talking to me? Leave your 3, carry your 6. And now that 9 has to go visit, he went to the ones place, now he has to go visit in the tens place. What number are we multiplying in the tens place? The 3. So 9 times 3 is 27 plus 6. 27, 28, 29, 30, 31, 32, 33. So now I'm going to mark off my 9, mark off my 6, and we're good to go. But remember, because we are shifting over from the ones place into the tens place, what do I have to do? What do I have to remember every time? My placeholder is a 0. So the 4 is going to visit who first? The 7. 4 times 7 is 28. Your 8, carry your 2. And now the 4 is going to go visit in the tens place. 4 times 3 is 12 plus 2, 14. 3, 8 plus 3, 11. 4 plus 4, 1 plus 0. Your comma goes every 3 numbers. Count with me. 1, 2, 3. 1,813. Okay. I don't have a second method of checking this, so it might be wrong. But that is the math that we are doing today. If you are to go on to the problem set, I will provide one digitally, but you also took home your paper copies. We're going to do the same thing during our 10 o'clock WebEx meeting if you're watching this before then. And I wish you luck. I'm going to stop sharing my screen now. And I'm going to bid you, oh, I'm so close. I'm so sorry. I'm going to bid you farewell. Adios.